Okay, so we're going to go over page 91. We're going to talk about different ways you got the answers because there were lots of different ways to get to the exact same answer. So on number 1, let me exit out of this at the top. Hold on. Let me get rid of that to make my screen bigger. I got to go all the way back down. Okay, number 1 says, here's a tape diagram that shows how far 2 students walked. It shows Priya's distance, Tyler's distance. What percentage of Priya's distance did Tyler walk? Now, walking around, I saw a lot of you had the right answer. What is the correct answer? 80%. Okay, let's talk about different ways to get that same answer. Okay, the answer is 80%. Who got that answer and can explain what they did? Brendan?
So if the top one's 100% and you take 1 off, then it's going to be 80.
Okay, so he said if this top one is 100%, that means they all equal 20. So if you take 1 off, that would be 80%. Do you agree with his logic? Okay. Anybody do it different? I know I saw a lot of you guys broke it into 20%, so we'll count that as the same thing. Anybody do it different? How many boxes does Tyler have?
4.
How many boxes does Priya have?
5.
Priya's distance, okay, so you're comparing Tyler to Priya. Tyler to Priya.
But wouldn't you take it times 2 first though?
4/5 is a percent is what? 80%. That works too. Or you could have said 2, 4, 6, 8, 10. 2, 4, 6, 8. Tyler to Priya. 8/10, is that still 80%? They all 3 get us to the same answer. Does it matter how you get there? No, whichever one is easiest for you and makes the most sense. If you get 80%, that way works. Now, if you use the 20%, or if you broke it into 20s to get 80, the next one might be harder to do, okay? If we did the fraction way, if we're comparing Tyler to Priya's distance now, or sorry, Priya to Tyler's distance, flip the fraction. 5 to 4 is 1 1/4, or 1.25, or 125%. If we break it into chunks like we broke that one into 20, how would we have to change our mindset on the part B? Hallie?
So for Tyler, his 100% was all like the 4 columns, so you would make it 25% for
Yeah.
each box.
Now we're calling that 100%. So that right there is 100%. So Priya walked over 100%, and Hallie said to figure it out, if I split 100% into 4, it'd be 25, 25, 25, 25, 25, which would give us 125.
So it wouldn't be as easy because they would maybe mistake it as like 120.
Yes, common wrong answer is 120 because we counted by 20s on bottom. Okay? Or you could have flipped the 10 over 8. 10 over 8, if you divide that out, most of you would probably just divide that out, you would get 1.25, which as a percent, 125%. So again, lots of different ways to get to the same answer. If you're flipping people, you flip the fraction. If you have percents, you got to go back to the fraction before you can flip it. Does that kind of make sense? Okay, number 2. A bakery makes 40 different flavors of muffins. 25% of the flavors have chocolate as one of the ingredients. How many flavors have chocolate and how many don't? Who can put that into the phrase that I've been trying to get you to pick out? Leo. 25% of 40. Okay, 25% of 40 equals blank. And I know that 40 goes here because it says 25% of the flavors. How many flavors are offered? 40. Okay, that's how I know, that's how I set it up.
But it says it made different flavors. But if there's more than one chocolate, wouldn't there only be one chocolate flavor?
So by flavors, it's not talking about individual flavors. It's saying like if you get a chocolate extreme concrete at Dairy King, there's chocolate in it. Or like the Oreo Blast probably has chocolate in it. The peanut butter lovers probably has chocolate in it. So it's not saying like individual flavors, it's saying which of the muffins have chocolate in them. So there's fancy muffins. Does that answer your question? Okay, who can tell me how they solved that? Leo, go ahead.
So you have to take the of is like your multiplication sign. So you have to take 25% times 40.
Okay.
And I made 25% a fraction, which is 1/4. And you have to put 40 over 1 and multiply.
Okay, if we multiply straight across, we would get 40 over 4, which is, oops,
Reduced to by 4, which is 10 over 1.
so 10.
Yeah.
So what does that answer tell me? Hallie?
10 of the flavors have chocolate.
Yeah, 10 of the muffins have chocolate in them. So 10 muffins have chocolate. Did anybody use the decimal form of 25%? What is the decimal form of 25%? 0.25. We could have also done this. If you have 4 quarters, how many cents do you have? 100, and I have to add an extra 0 because of that 0. And then 2 decimal places. Did we still get 10 muffins? Okay. Does that answer all of my question? If there are 40 flavors and 10 of them have chocolate, how many do not? Ellie? 30, yeah. So 10 have chocolate. I'm going to write 40 minus 10 equals 30 do not. What if it asked what percentage of the muffins don't have chocolate? Brendan? 75%. Why?
Because if it's 100 and you take 25% away, then it's going to be 75 because
Yeah. If I took 75% of 40, what would my answer be? 30. We already know that, doing it a different way. Okay, number 3. There are 70 students in the school band. 40% of them are 6th graders. I'm going to underline them. What is them referring to? Owen? What is them referring to? 40% of them. No?
Students in the school band.
The band. 40% of the band are 6th graders. How many band members are there? 70. So 40% of the 70 are 6th graders. 20% are 7th graders and the rest are 8th graders. How many band members are 6th graders? What is my math problem, Dawson? What's my phrase that can help me here? How many band members are 6th graders? What phrase could I pull to help me with that?
I used a state diagram.
That's fine. You still would have had to think about this. Hallie?
40% of 70.
Yes, we are looking for 40% of 70 because 40% of the band are 6th graders. Lily, how did you solve this?
0.40
Okay, so you changed it to the decimal form. Times 70. Lily, what's 4 times 7? 28, and then I have to add my 0. Where do I put my decimal point?
after the 8.
Yeah, it's because there's one decimal place, one decimal place. So that means that 28 students in the band are in 6th grade. Meyer, for part B, if it says how many band members are 7th graders, what do I have to do? No, because there's a third part in this one. If it was just 2 of them, yes, I could flip-flop it, but since we're talking about 6th, 7th, and 8th, what percent are 7th graders? 20% of what? So 20% of 70. Now, we could do 0.2 times 7 and get the answer. What else could we do? Dom, what did you do? If I know 40% is 28, how did you find 20%? Okay, why can you just divide 28 by 2? Yeah, because it's half, and we're taking a percentage of the same number. That only works because we were doing of 70 of 70. We're working the percentage of the same problem. So Dom just saw that it was 28, and 20 is half of 40, so he took half of 28 and got 14. You don't have to do that. If you don't think like that, that's okay. 0.2 times 7, is that a hard decimal problem? No. What's 2 times 7? 14, add my 0, count my decimal places. Did we still get 14 students? Yes. Now, part C could ask 2 different questions. It asks one, I'm going to ask the second question. Part C says, what percentage of the band members are in 8th grade? Ellie?
You add 40% and 20% and then subtract it from 100%.
Yes, because when we add the percentages, they have to equal 100%. So she said she added 40 and 20 and got 60%. So to find that one, she took 100 minus 60 and got 40. So 40% are 8th graders. 40% are 8th grade. What other question could it ask? Leo?
How many students are 8th graders?
Yeah, how many band students are 8th graders? How can I do it without taking 40%?
Look at 6th grade.
Yeah, we already found 40%. What if it was a different percentage?
Then it wouldn't equal.
Well, let's just pretend they all add up to 100 still. How could I do it without doing a percent problem? Afton?
I did it a different way. I added the 6th graders and the 7th graders, and then I subtracted it by 7.
Okay, but that gave you the number of students, that's the question we're answering now. So to find that number of students, she could add 28 plus 14 and subtract it from 70, but it would give us 28 because it's the same percentage. Did you get 40%?
No.
Okay, so you got 28 students, which is correct, but it doesn't answer the question because it says what percentage. So be careful because that's a common error. It could ask us either one. It usually doesn't ask us both. It usually asks for one or the other. Okay, flip over to, we're going to start lesson wait, hold on. I wanted you to turn to the next page. Number 4, I want you to try number 4 right now. Try number 4. I want you to try and come up with the phrase that we've been picking out. Percent of whole is part. Fill in whatever you can in that percent equation. Percent of whole is part. And then try and solve it. You don't have to use a number line or a tape diagram. You don't have to use a double number line. Who has the phrase? What phrase do I need to solve? So it says, Jada has a monthly budget for her cell phone bill. Last month, she spent 120% of her budget, and the bill was $60. What is Jada's monthly budget? Explain or show your reasoning. Who can come up with my phrase? Look for the percent. It's always close to the percent.
120% of 60 is
So underline that right there in the book. 120% of her budget. I'm going to start writing it down. 120% of her budget. Do we know her budget? No, because the question says, what is her budget? Which means this is what we do not know. So I'm going to put a blank there, or we could put a W. What's W going to stand for? Whole. 60 is the part. That's what she actually spent. Now, we're going to use our logic here. Is our whole going to be bigger than 60 or smaller than 60?
Smaller.
Why? Hallie?
Because she went over 100%.
Yeah, because it's over 100%. I know 100% of 60 is 60. Okay, so my whole is going to be smaller. How can I solve this? Ellie?
I divided the book by 6 to get 20% and 10, and then I multiplied them by 5.
Okay, did you set it up as a ratio or how did you organize it?
So I just said that 120% equals 60.
Okay. Okay, so you just kind of showed, so you divided them both by 6. So you got 20% is equal to 10? Okay. And then what? Okay, and then she's trying to get to 100%. Okay, so times 5 times 5. That's 100%. And that's 50. Does that answer make sense? Okay, it's bigger than 60, or it's less than 60, so it does make sense. You might work it a different way and get the same answer. Again, there's lots of different ways to get there. My brain doesn't work like that. Okay, so most of you did it that way? They might just do the math. See, I like equations. I like, right here, if we have 120% of a number equals 60, that's 1.2 times blank equals 60. What math could I do to solve that?
60 divided by 1.
Yeah, 60 divided by 1.2, which is 600 divided by 12. How many times 12 go into 60? 5. Drop a 0. Do I still get the same answer? Yeah. And it doesn't matter how you get there as long as you get there. Okay, I'm giving you options. Next week, we're actually going to start the worksheet today, but you're not actually solving anything today. Next week, you are going to solve lots of these problems 2 different ways. You're going to solve them using the equation and the percent proportion, which we haven't talked a ton about, which is kind of how you guys are doing it here. Turn over to lesson 13, which should just be on the next page, correct? We're going to start the notes for lesson 13 today, but we're probably not going to get through them all. Benchmark percentages. These are the common ones. Okay, the ones that you probably have memorized. When you're looking at a model, how do you decide what percentage is shaded? Jake, where could you start first?
You could put it into a 1/10. You could put it in a fraction and then put it into percent.
Okay, yeah, so when we look at that, most of you either think 1/10 as a fraction, because 1 out of 10 are shaded, or you think 0.1, because if I did it as a decimal, it's still 1/10 of them are shaded. Do we know how to change decimals and fractions to percents? Yes. What is 1/10 as a percent? 10%. So A is 10%. What's the fraction for B? Leo? 1/2. What is the percent for half? Percent. 50%. See where those common fractions decimals are helping? Jake, C, what's my fraction? 3/4. What's that percent? 75%. Okay, so they can give us a model like you would have seen in 4th grade, 5th grade, and now we can give it another number to go with it.
Miss Jillian,
Yes?
I promise this is the last time I'm going to bother you.
That's okay.
Can you send Brendan Houston and Aubrey Ritter to the computer lab?
Yep.
Thank you.
Yep. Do you got the one across from the office? Okay, let's go down to 13.2, which for you guys is on the next page. Meters, liters, and hours. How much is 50% of 10 liters of milk? 5. What did you do? Divided by 2, because if we're taking half, we can just divide it by 2. And what they're wanting us to show, if we have to show it, is I have 10 and I'm dividing it in half. What would each of them have to be? 5. So I'm just going to show it here. So that would be 5. How far is 50% of a 2,000 kilometer trip? 1,000. So to find 50% of a number, really all you have to do is divide it by 2, because you're taking half of it. So this would be 1,000. Ethan, how long is 50% of a 24-hour day? 12 hours. Afton, how can you find 50% of any number?
Divide it by 2.
Divide it by 2. What multiplication are we doing if we divide by 2? Times 1/2. So in parentheses, I'm going to put times 1/2, because that's the same thing. Second part says, how far is 10% of a 2,000 kilometer trip? If we're taking half, we divide by 2. What is 10%? What fraction? 1/10. How do I take 1/10 of a number? Times 1/10 or divide by? 10. When we divide by 10, what does it do to our zeros?
Takes it one away.
It moves the decimal place 1 to the left or cuts off a 0 if there is one. So what is 10% of a 2,000 kilometer trip? 200. Leah's looking at me like I'm speaking Spanish. So because, let's go ahead and take a couple notes. 10% is 1/10. So when we take 1/10 of something, 1/10 times something, we're really dividing it by 10. So if it has a 0 at the end, it'll just chop a 0. If there's not a 0 at the end, it'll just move the decimal place 1 to the left. So 10% of 10. 1. %10 of 24. Is there a 0 I can chop? No. So we have to move the decimal place 1 to the left. 2.4. How can you find 10% of any number? Well, what math are we actually doing? Dividing by 10. But since it's a power of 10, we can just move the decimal place. Divide by 10, and in parentheses, I'm going to put times 1/10. Next one, 75% of a 24-hour day. Usually this one's a two-step thought process. Leo?
18.
What did you do?
I split it into, because you can make 75 into 25%.
So find a fourth first. So I know that 75% is 3/4. But I can find 1/4 of most numbers. How do you find 1/4 of a number? Divide by 4. And if you need 3/4, then you would. Okay, let's start. What's 1/4 of a 24-hour day?
6.
So 1/4, I'm going to write 1/4 equals 6, but I need 3 sets of that.
Multiply 6 by 3.
Times 3 is 18. So let's do the same thing. 75% of 2,000. What's 2,000 divided by 4? 500. So I know a fourth equals 500, but I don't need a fourth. I need 3/4. So now what do I do?
Wait, what is that number?
That's 1/4, sorry. Times 3 is 1,500. So we're breaking it into a benchmark percentage. We're breaking it into a unit fraction. Remember those unit fractions that we've talked about? Because we can easily multiply by a unit fraction, we just divide by the denominator. And then we build it up. So what's 1/4 of 10? This one's a little bit trickier.
2.5, yeah.
Okay, or leave it ugly, 10/4. So 1/4 would be 10/4. How'd I get 10/4?
What is the fraction of 2.5?
10 divided by 4. How many of those do I need?
3.
3. So I'm going to do times 3,
30.
30/4.
Oh, yeah.
And then we can divide it out. How many times 4 go into 30? 7.
7.5.
Yeah, 2/4, which would reduce to 1/2 or 0.5. So how can you find 75% of any number?
Get it to 1/4.
Find 1/4 first. Find 1/4 first. Then multiply by 3. And that logic works on a lot of problems. Unit fractions are easy to get to. So if you needed 3/7 of something, and let's say 3/7 of 49, could we find 1/7 of 49?
Yeah.
What's 49 divided by 7? 7, but then yeah, we would need 3 sets of that, so you could multiply it by 3. Okay? We might stop there for today. Let me see. Yep, we're going to stop here for today on the book. Let me pause this and pass out. Okay. On the worksheet, let's read the directions at the top together. Again, you are not doing any math tonight. You're not solving anything, okay? You're doing the first part of completing this worksheet. So it says, in the problems, there are 11 of them. Why is that off? Did I miscount? 3, 6, 9. There should be 12.
There's 2 3s. Yeah, there's 2 3s.
Okay. There we go. There's 2 3. So the 12 problems that are misnumbered. You are just locating the percent, the whole, and the part from the problem. Label them with a percent sign, a P, and a W. So we're going to pick out a couple of them. Notice I double spaced the sentences so you have room to fill that in. So let's just go to number 4. It says 15% of the number of people who attended the concert arrived late. If 30 people arrived late, find the number of people who attended the concert. We're picking out the percent, the part, and the whole in the problem. Which one's easiest to pick out? Leo? The percent. So I'm going to underline this, and either above it or below it, I'm going to write percent. That's my percent. I picked it out. If I were you, I would underline this next. How can that help me?
It's always the multiplication sign, and so you multiply the number of people who attended the concert.
But we're not solving anything. We're just trying to pick out our part and our whole. What's my phrase?
It's
Percent of whole is part. Percent of whole is part. So now I have to decide, is my whole something I'm looking for, or does it give it to me? It gives me 30. Is 30 the number of people who attended the concert?
No.
No. So what is my whole in this one?
We don't know.
We do not know it, okay? But I'm going to underline that because it is the number of people who attended the concert, but I don't know how many people attended the concert. So what does that mean the 30 is? 30 is my part. Okay, so for each problem, you're going to go through and identify those 3 pieces. And it says, put it in the form percent of whole is part. So there's some space at the bottom. You're going to write 15% of W is 30. Oops, I should have wrote is, because we're not solving it right now. On this step, you will either have, if it's the percent, just put the percent sign if we don't know it. If it's the whole that we're missing, we're going to put a W. If it's the part we're missing, what do you think we're going to put? A P. You can't put P for percent and part. So we're going to do the percent sign for the percent. And for tonight, that's all you're doing. So really, you don't need that second sheet yet. So when you come tomorrow, you should have 3 pieces labeled on each and a new phrase written. We're going to do one more together. Pick a number, Owen.
I have a question. What do we do for the first 4? Because
Okay, let's do one.
it's already in the form pretty much.
Yeah, so it's easier.
You just have to flip some of them around.
In the hole. It says.
Okay, let's do number 2. Or which one? 1, 2, or 3? Jake, pick one.
1.
What number?
1.
Number 1. Okay, locate the percent first. If it's not given, if you don't see a percent sign, that means that's what you're looking for. So what is the percent in number 1, Jake? 15%. So I'm going to put a P above 15%. Percent of whole is part. So what does my whole have to be? Elise? 40. So I'm going to put a line under 40. That's my whole. And could I rewrite this as 15% of 40 is blank? Or is what number? Yes, so what are we looking for? The part. So I'm just going to underline what is. Oops, that should be a percent sign, sorry. And I'm going to put a P there. So how do I rewrite that phrase in percent of whole is part? 15% of 40 equals, or sorry, is P. Let's do one more. Pick a number, Afton. 3? You want to do that one? Not a harder one down at the bottom? I don't care. We can do 3. Okay.
3. The bottom one 3. No, she said 11.
3 or 11, Afton? 11. Okay. That one's kind of tricky. I think if you think about it, you'll figure it out. Ooh, don't stop. Number 11. Is it still recording? Yes, we're good. That should say Bruce cooks, not cookies. That's a typo. So Bruce cooks 80% of the pancakes at the pancake breakfast. My marker just went out too, so I don't have my button. There it is. Okay? What is my percent? Ethan, that's easy to pick out.
80.
80, so I'm going to underline that. I'll put the percent sign under it. Of the pancakes. I'm going to underline the pancakes. So he cooked 80% of the pancakes at the pancake breakfast. They made 1,120 pancakes. How many pancakes did Bruce cook? Percent of whole. My whole is the number of pancakes at the breakfast. Do I know that number or do I need to find it? I know it. So Tatum, what is my whole?
1,120.
Yes. So this right here is the same. It's referring to those pancakes. So this is my whole. So what am I looking for? The part. How many did Bruce make is my part. Who can put that into my phrase? Ellie.
80% of 1,120 equals part.
Is part. Yep, is P. This is probably the hardest part of percent problems, is getting them to make sense. Deciding, is it giving me my part or is it giving me my whole? So tonight's homework, that's all you have to do for these 12 problems. Label the 3 pieces and write the new phrase. You're not solving anything. You're not solving anything. Just try it. Think about what that means. What is the quotient of 15 and 3? Put is here, because when we write the equation, we'll change it to an equal sign. Okay, so your homework is just to come up with, finish this page. Do you have to do any math? No. No, you are just organizing the information right now.